Okay, so let's look a little more into the RAM software. I'll just kind of walk you through some generalities. So along the left is this spreadsheet mode, which is kind of the mode I like to work in. So as you're working, let's say you select a member, you can come in here, see what size it is. I can change that size by double clicking here. I can assign materials, so maybe this is concrete. I can change that. If there's shells, I can come here and say, okay, the thickness here is 18, the material is C4-60. The orientation, I may want to look at that and turn on the axes. I can also make those numbers bigger down here. Anyway, so basically I can start with assigning nodes. Sometimes there's faster ways to generate those by importing things. It just depends on what I want to do, how I want to do it. Let's see if I can move that up a bit. Okay, so anyway, so nodes, I can assign boundary elements. In this case, if I turn on the springs, well, I'll wait for a second. So I have some horizontal boundary conditions. The springs are quite extensive, so I won't turn them all on, but basically I've assigned a spring stiffness related to the soil properties. Um, I can come in and assign fixity on the members, so you can see some of these members are rigid, so there's no pins, and then in the brace frame directions, there's two things going on. One is these beams are hinged at the end, so it's a pin connection. These braces, that little thing indicates it's tension only. So here where I come to this, I can decide tension only, full, and then different levels of end restraint or different types of end restraint. All right, so back to nodes, springs. I can apply loads specifically to nodes. I don't know if oh yeah, I did do that here. So you can see here, I can turn on those loads which correlate to these guys here. All right, on members, these are the line elements, and the way these are created is I select two nodes and I can say connect nodes with members or alternately connect nodes. So if I wanted to do something like this and say alternately, it would connect like that. If I didn't do that and said connect nodes, it's going to do it in the order I selected those nodes. Similarly with shells, let's say I want to put a shell in a plane from that node to that node up to here. So I can come in here and say create the shell, and now it's created a shell at some funky plane. And sometimes, well, it's best to go in a clockwise order and then use this create quadrilateral. Sometimes the shell will give you like an X looking shell, which just means the order that you selected the nodes was not happy for RAM. So you just have to kind of play around with it. So that one got, let's see, let me try that again. So that works, and then if I do quadrilateral, see it gives that X. So it's just the order, and I have yet to figure how it thinks. So I just play with it till it works. Okay, so on members, we can assign sections. So all the different types, I could turn that into an angle. I can render this and see that now my model looks really funky because I had big members and I changed it to an angle. I can assign different materials, so structural steel, most wide flanges are A992, and most angles are A36. end conditions, and then something that's important for beam design is what the flange bracing points are. So I can come in here, and in this case I don't have anything assigned, but I could say it's either not braced along the length, it's braced in the middle, the third points, whatever. I can just do that based on what really is going on in reality. Okay, I think that's good there. Oh, loads. I can come in here and assign loads that are actually along the length of the member. So if I said 0.1 kips per foot, hit OK, put a line load there, that's going to run at the same time as these other point loads that I put in the nodes. So maybe I want that to be horizontal. I can come over here and say go in the X direction. Now it's going in the X direction, but negative because I have negative values in here. So I can play around with that as much as I want. If I wanted to change the direction, I can multiply those by -1, and it'll change the direction. So honestly, you guys will learn this probably pretty quick because you're computer savvy. I would say just play around with the buttons, see what they do, and just experiment. You're not gonna, if you're working in a model you care about and you want to experiment, I find that just saving it as a new name goes a long ways. Okay, let's see. So that's that. Shells we talked about a little bit, so we can, like this shell here would tell you what nodes it's connected to, what the thickness is, what the material is, what the mechanical cover. So that's how much space between the edge of concrete and the edge of the rebar. The axis orientation is important for shell, understanding the shell results. You can flip the orientation. So usually what I find I have to do is find a shell that I like the orientation and then select the rest of them. And then I can come in here and say flip, align the axis towards the first selected node, which you can see I've done that at some point. What I like to do is have axis 1 and the X and axis 3 and the Z parallel. That way the results make sense to the global axes of the project. All right, I haven't played with these much, but that's certainly something that would be worth your time. I don't use much by area, some people do, and then general for my dead load case, I like to have -1, which basically says include the weight of all the material on this project as a dead load, then I don't have to calculate that individually. All right, once we have the model established and we have loads, I can go ahead and run the model by hitting the Analyze button here. And I can turn on P delta, which is usually a good idea. It doesn't run with tension-only members, so I'm not going to do that in this case. I can decide which load combinations to run. I can have a little bit of play on the element size. I can choose kind of what method it uses, what finite element engine, whether I'm in core or out of core, how I use the CPU. I just usually leave it at default unless I have trouble with the model running. Then I'll play around with these. And then degree of freedom, I usually keep it on automatic, but we can choose others, which sometimes simplify things. All right, once I'm ready to analyze, I can hit the run button, and this will go for it. This may take a hot minute because of the tension only and the shells, so I'll cancel. Well, let me just come back when this is run. Okay, so the model's complete. Down here, it'll tell me if there's warnings and errors. It looks like everything's cool. Don't ignore those. If you get warnings and errors, figure them out until they get all cleared. Otherwise, you can't really trust fully your results. Okay, so once I have that, I can come in here and say, I want to see the bending moments. I need to go to a load combination that's been run, and I can turn on those values, and I can see what's going on moment-wise in my structure. Or maybe I want to see shear-wise or axial force. Lots of choices there. If I want to look at reactions, I can come here and look at the reactions. This has given me those spring reactions and also any horizontal reactions. Lots of information, turning off and on things, changing the scale of the text helps. But you can play around with that. If I want to look at the deformed shape, I can do that. So I'll turn on everything. And now I can see what the loading has done to the structure. If I want to look at what the actual displacement of a node is, I can do that. Turn on XY, I can even turn on rotations. If I want to look at stresses in the mat foundation, I can turn those on. And I'll need to come to moments. And if I turn on the edges, it shows me my elements. If I turn on the max, it'll sometimes do something. If I do envelope, it shows me all of the load combinations, the maximums or minimums of all the load combinations. I can go to moment about the 3-axis and see those moments. The bottom line is this is months and years of understanding, so I'm just giving you a really quick high-level view of what the software can do. It really just comes down to picking your way through it nice and slowly and understanding what's going on in the model. For me, understanding the element results is a lot easier than understanding the shell results. So when I do shells, I have to slow down and look at the manual and make sure I understand it. When I do elements, I can turn on the stress ratio and I haven't run it, so let me run the design module here. So that's kind of the next step is I can check it against different codes. I can also do some seismic design. Anyway, so I'm going to hit run. This may take a minute. Oh, it looks like it's going pretty fast. So right now, in about 10 seconds, it's checking things that by hand would take at least a day. So anyway, I can come here and see that I have one member that's red. So that's overstressed. I can say, okay, how far overstressed? So that's 210% stress, so 110% overstressed. I can look at specific members and see what their ratios are. And I'm doing for the controlling combination. So if I uncheck that, I may not be getting the maximum stress ratio. So I like to keep that checked. Something that's pretty cool is I can come to output here, design, still, I do concise, you can do comprehensive, and I can pull up all the design checks for that member per AISC, which is exhaustive. You can see if you were to do this by hand, that'd be several hours once you're comfortable with it, maybe several days when you're learning it from scratch. Anyway, there's a tremendous amount that's going on, and the software, good software that's reputable, is well vetted and tends to be accurate. Where I find I have problems is where I don't understand what's going on in the software, or I just fat finger something. So this is where validating your results really comes into play, is taking your time, understanding why you did things a certain way, and making sure that the model, what you told the model to do is what it understood, and the results match what you expect. All right, so the easiest way to learn this software is by doing it. RAM gives you a student version of this for free. So once you create an account with them with your uvu.edu email, then you're able to access their software. Um, we also have it in the lab in CS 510, so I will see you there for class and get into this more in depth.